Hi everybody and welcome. Today we're going to be taking a look at definitions and characteristics of angles. So your goal after watching the video today will be able to identify the different types of angles you're going to see and also identify the different parts that make up an angle. As you can probably tell by the front of your sheet, a little bit of a definition heavy day because we're introducing a new concept. So we're going to start off with 3 definitions and then we're going to start working into practice problems. As always, important to note with geometry, these definitions and these small pieces, they really do matter. So something that you're going to make sure of is all the little details that we're about to be going over here. We want to make sure that we're carefully copying them down. That way, if we see differences in capitalizations or how we draw a line or an arrow, all of that matters in terms of getting answers correct or incorrect here with geometry. So with that being said, we're going to jump right in. Our first definition here is ray. And a ray is a part of a line with one endpoint and one side extending infinitely. So a couple of key things to note for this definition: endpoint and infinitely. So endpoint means that it's just a point, it stops. But infinitely means it keeps going on forever and it never stops. So a ray is just that. One half of it on one side stops and the other half never does. So what we're going to see for the endpoint here, I'll label it. So there's our endpoint, is that's going to be the point where we don't go any further to either whichever direction it stops in. So here we're not going to go any further to the left. That's the endpoint there. So if we have R as one point here, and S is just a point on the line. It's not where this ray stops. It just happens to be on the line. That's another way that we can take a look at some of our points. So how we label these is we use 2 points that are on it. So R and S are both on this ray. And we show that it extends forever. And the important thing to note is R does have to be the term that goes first because it's the endpoint. So if we were looking at something like this, where we had S and then T, we would actually have to label this one of 2 ways, ST or TS this way, but the key point is S is the one that is attached to the endpoint. So that does matter that S is in that exact direction in that composition. So nothing too crazy with rays, but just be careful with which point is your endpoint. Second definition here is angle. An angle is when we have 2 non-collinear rays with a common endpoint called a vertex. So non-collinear means that they just don't share the same line. And the second thing to note here is we have a common endpoint, and we call that a vertex. So let's say we have one ray here, and then we're going to share an endpoint, so we'll put another ray here. So this is their shared endpoint, their common endpoint. And then the second thing to note here is non-collinear, is that if we take a ruler out, we're going to see that these are not on the same line. They're not on the same ruler. They occupy 2 different spaces. So because of that, we know that this fits our definition. So we would also want to put a couple of points here. Again, these aren't endpoints. So A and C, those aren't endpoints. Those are just points that happen to be on the ray. But B is the endpoint. The way that we label angles is we actually have to have our vertex, or our common endpoint, that must be in the center. So we can do angle ABC, or we can do angle CBA, but there is no other combination that works because this B must be in the middle. So no other options there. B has to be in the middle. So if you don't have your common endpoint in the middle, you will get that angle wrong. So very, very important that common endpoint does, in fact, occupy the middle. All right, our last definition for today is starting to put a few of these things together now. degree. So degree is an angle measure that results from dividing the distance around a circle into 360 pieces. So if we were to just look at a circle to start off with, all that we're doing is we're going to make 360 little, and don't actually do this, but 360 little tick marks all the way around the side of it. And if we were to take our little angle ABC and redraw it inside of this, put it in a circle, all that we're doing to count the degrees of this little angle is just to count off how many of these little tick marks go from one edge of the angle to the other edge. So that is a technical definition of degrees. So let's say here, I don't know, maybe I counted that 8 degrees, if that actually was the accurate representation. So if that is 8 degrees of a circle that angle occupies, then that is a technical definition of how we just solve for the number of degrees that are in an angle. So again, the idea here is we are just counting the number of parts out of the 360 in a circle that an angle occupies, and that tells us the degree measure of that angle. So there's a lot that we can get from degrees of an angle, and some other definitions to keep going with. So the first thing is some steps to remember. An angle is formed by two non-collinear rays that have a common endpoint. The rays are called the sides of the angle, and the common endpoint is called the vertex. The symbols that we can use to label angles are like so. We use all 3 letters. And the key is that our common endpoint must be the middle letter when we are naming this. The second different thing that we're going to be looking at today is classifying angles based off of their measure. So a right angle is 90 degrees. I'll put that down there. An acute angle is any measure from 0 to 89 degrees, or 89.99999, but you get the idea. An obtuse angle is anything that's bigger than 90 degrees, so technically 90.00001, but we'll just, for simplicity's sake, anything from 91 to 180. So again, the idea here, bigger than 90, less than 90, and exactly and only exactly equal to 90. So what you're going to see here is in a circle, this would take up 1/4 of 360, or 90. In this one, the angle starts here and it goes all the way over here, so it's going to take up more than 1/4 of a circle, so more than 90 degrees. And here, this one starts here and it stops actually pretty shortly, so it doesn't even take up 1/4 of a circle, it doesn't even take up the 90 degrees that we're looking at. So that's the idea for the 3 different types of angles that we're going to see. Next up, different types of questions that you're going to see. They might ask you to just say, hey, is it acute, obtuse, or 90? Or they might ask you to name some angles. So first, starting off by naming some angles that have W as a vertex. So if we have W as a vertex, so let's see. So there is one option. So angle XWZ. See what else we can do. We can still use X and W, except this time instead of Z, we can make it a nice obtuse angle. So angle X, W, and Y. We can keep going with this idea. We have to be careful if we're on the same line here. Technically, this is something called a straight angle, so that would not be something that we would necessarily want to label, because if we look back up at our definition, an angle is formed by 2 non-collinear rays. So that means that if we were to use this ray and this ray, they share the same line, they're technically collinear, so we couldn't use X, W, and V. But we still have some other options. that one has W as a vertex. So we could do ZWY. And again, use this friend over here as well. ZWV this time. And one more option. We can use YWV as well. So basically just looking for everything that's not on the same line that has a common endpoint there of W. And if we do that, we should have at least 5. Maybe I missed one. Let me know if I did, but hopefully those should be the 5 that we're really looking for. Second question here is asking us to name the sides of angle 1. So angle 1, it goes from here to here. It has that little 1 in the side there. So name the sides of it. So I'm going to have you answer that in Canvas now. So the two sides here, we do have to be careful. These are rays, WX with W as the endpoint, and a second ray, WZ, again, with W as the endpoint. So be careful that W is the term that is the start of your ray. Next one here, write another name for WYZ. I'll have you do that now. And let me just define, again, WYZ in case it's hard to see. So WY to Z is there. So let's write another name for it. So two options actually are correct. We are allowed to use ZYW as long as Y is the term that's in the middle. A second one is we can actually just call it angle 4. And again, that's allowed because we can do that. You can see up here, you can use the number that is right next to your vertex, and that allows you to name the angle. So using that information now for part D, name the vertex of angle 4, I'll have you answer that one in Canvas. So we actually just have angle 4 highlighted already on the screen, and 4 is actually circled here. So the vertex of this, or the common endpoint, is Y. All right, the last thing to just take a quick look at here in example number 2, we're only going to do a couple of these. Again, just start off with highlighting, and what they want us to do is label right, acute, or obtuse. So they want to go for angle T to Y to V. So from T to Y to V. And here what we can see is, on this side we have a right angle marked off. And we can also see that this is a nice straight line here. So because that's a nice straight line, we know that it has to also be 90 degrees on the other side. So because of that, we can say that T to Y to V is a 90-degree angle because it is the other half of a straight line. So let's do our next one here, and this will be the last question I ask you for today, is say if it's right, acute, or obtuse, and let's look at WYT. Is WYT right, acute, or obtuse? So WYT. All right, so after taking a look at this one from W to Y to T, it is greater or bigger than 90 degrees. So we're going to say that we are obtuse. So that is an obtuse angle. It is bigger than 90 degrees because we can see inside of it. We know that from here to here is 90 degrees. It's a quarter of that straight line. So it's more than that. So we know that because we're more than 90 degrees, we are obtuse. All right, everybody, if you got questions, let us know. But if things are making sense, you're ready to jump right into those practice questions.